This video is really the second part of problem 22. In this particular video, my focus is on multiple regression analysis, and that simply means is what is the best equation, what is the best multiple equation that we can use to forecast selling price. If we go back and we look at our data, right, selling price would be our dependent variable, square footage, age, and bedrooms would be the three independent or predictor variables. And from what we've already done, we've seen that if we just look at square footage and selling price, that by itself, i.e. square footage, would be significant to use in forecasting the price. Likewise, right, if we just used age by itself, it was also significant. And if we just use bedrooms by itself, that was also significant at the 0.5 level of significance. So from that standpoint, yes, each independent variable by itself would be significant in forecasting selling price. And then you were asked, as we explained, I should say as I explained in the previous video, if you had just to pick one of the independent variables, which one would it be? Well, that one would be the one that had the highest R square. So if we go back and we look at square footage, our R square coefficient of determination is just about 70%, 0.69999, right? So that simply means that, in other words, just about 70% of the behavior of our selling price, the reason why some homes are more than others, can be explained away with square footage. If we look at age, well, age would be slightly higher. And if we look at bedrooms, only 43%. So if we just had to select one, that selection based upon R square, the coefficient of determination, would be age, because it has the highest R square. Now, focusing in on multiple regression, we know that, in other words, if we can explain away 70% of the behavior of our dependent variable with a specific independent variable, that simply means we have, 30% that we can explain away. So maybe there's something else out there that would help us. That's where multiple regression comes into play. Now, I'm going to go over this pretty fast, so bear with me, because I'm going to incorporate in this video what is referred to as stepwise regression. And in stepwise regression, in other words, we will introduce one independent variable at a time into the model to find out if we can add independent variables to the model to help explain away more of this variability that is going on between and among the selling price. So the first thing that one would do, if one has more than one independent variable, is to do this correlation matrix. And in this correlation matrix, we have it set up with our selling price, square footage, age, and bedroom. It's simply a correlation matrix. So of course, if we correlate selling on selling, we would have 1 or 100%. If we take selling price and relate it to square footage, we would have 83.66, age 83.82, and bedroom 65. Now, what is interesting, when we have more than one independent variable, we want our independent variables to be independent of each other. I'll say that one more time. When we have more than one independent variables, we want those independent variables to be independent of each other and not dependent. If they are dependent upon each other, we refer to that as a measure of collinearity. So collinearity is isolating on independency or dependency of our independent variables. And the benchmark that we use in statistics is that if the correlation between our independent variables happens to be 70% or more, we could have a problem with collinearity, i.e., our independent variables are not really independent of each other. And we can see that right here. Square footage and bedrooms is 77%. That's a red flag. That's a red flag. So when you see anything that is more than 70%, the correlation between our independent variables, we could have a problem, which I'll point out here shortly. So let's go back over here. So stepwise regression in regard to multiple regression is that we're going to introduce one independent variable at a time. Which one gets into the model first? Which one do we analyze first? Well, it's the one that has the highest correlation. Selling price, square footage, age, and bedrooms. And we can see right here that age has a slightly higher coefficient of correlation than square footage. So that'll get into the model first. Well, if we come down here and if we look at age, right, just what we did previously, we are saying, okay, is age good? Is age a good predictor of selling price? And of course, we've already isolated and we said, yes, of course it is, because the p-value is less than our level of significance of 5%. So that's great. That's good. So what we do next is that we will go back in, and this time we will add to age the next highest independent variable. And of course that was square footage. So what we're going to do now is we're going to add square footage. We're simply adding another independent variable. And as you can see, what I've done here is that I've added square footage and age. And I'm simply going to look at it from the standpoint of, okay, how about now? I have two independent variables, and we do the same thing that we did previously, i.e., we look at the p-value. P-value, yep, very small for square footage, very small for age. These two are significant. They stay in the model. So lastly, we're going to go back and we're going to say, okay, what about the third one? What about the third one? And you can see here, if I go back, the adjusted R-square, let me go back to age. You can see the R-square was 70%, right? 70%. When we put square footage and age in, we jump to 86%, and the adjusted R-square is 84.8. Let me just digress here for a second. When we have one independent variable and when we look at our summary output to analyze, we always focus in on the adjusted the R-square. When we have more than one independent variable in the model, our focus is always on the adjusted R-square. My point being, when we went from age and we included the square footage and age, you can see we went from 70% when we just had age to 84%, almost 85%. So we have increased the amount of variability that we have explained away. That's positive. That's what you always want to see. Okay, let's go back and we're going to say, okay, I got one more independent variable. Let's throw it into the mix. And when we do that, I can immediately see something here. My adjusted R-square went down. It was 84, and now it went down to 83. Something's wrong. And remember I said, when we look at that correlation matrix right off the bat, that correlation matrix here, square footage in bedrooms, it was over 70%. These two independent variables are not really independent of each other. And we can see what's happening here when we threw in the mix into the model bedrooms. My adjusted R-square, my adjusted coefficient of determination went down, and look at the p-value. Square footage is still good. Age is still good. I have a very, very high p-value for bedrooms. So bedrooms will not stay in the model because I want my adjusted R-squared to always go up. It went down. So what is the best model to use? Right here. We only have two of the independent variables. So my model would be, right, selling price would be equal to my y-intercept of 94,195 plus my square footage of 31.45 minus my age of 1504. That would be my model that I would use to forecast selling price. That's the best, that's the robust, because that ends up with the highest adjusted R square. So the bottom line of the three in regard to multiple regression, and we utilize multiple regression, right, because we want to be able to explain away as much as possible of that variability that's going on between and among the values of our dependent variable. So square footage and age is what we would use in this particular model.